What we have here is a fairly long subtraction of rational expressions. Both denominators do need to be factored first before finding that LCD. So I'm just going to factor both of these using the trial and error method. I can see that because the last term is positive and the middle term is negative, I want these signs to both be negative. That is the case for both of these expressions. So the first one, 2 and 5 are the numbers that work. And for the second one, 3 and 5 are the numbers that work. Now that both denominators are factored, I'm ready to go ahead and find my LCD. It needs to include the factor y minus 2 and y minus 5 from the first expression. And then it needs y minus 3 from the second expression. And we already have y minus 5, so we do not include a second copy of the factor y minus 5. I'm now ready to start modifying these as necessary. 3y over y minus 2 times y minus 5. This denominator is missing the factor y minus 3, so I have to multiply both the top and bottom by y minus 3 in order to build up the LCD in this denominator. My second rational expression, 2y over y minus 3 times y minus 5 is missing a factor y minus 2, so I am going to multiply both the numerator and denominator of this by y minus 2. Again, in the next step, I am ready to subtract the numerators because I have now the same denominator in each of these rational terms, and I'm going to write it out in full detail without doing any of that distributing or simplifying yet until we have it all in a line where we are much more likely to distribute correctly. So my numerator is 3y times y minus 3 minus 2y times y minus 2, and my denominator is the LCD. We will substitute those factors back in at the very end. I'm now ready to distribute, bringing in the whole minus 2y to both of these terms, and bringing in the whole 3y to both of these terms in the first expression. This gives me 3y squared minus 9y minus 2y squared plus 4y all over the LCD. We are now ready to combine like terms and check to see if this can be factored. My like terms are 3y squared and minus 2y squared in the numerator, as well as minus 9y and plus 4y also in the numerator. So the 3y squared minus 2y squared gives me y squared. The minus 9y plus 4y gives me minus 5y. And I still have this whole expression over the LCD. In the very next step, let's start working over to the left where we have some space. In the very next step, I'm going to put the LCD factors back in, and I'm also going to factor the numerator. The numerator has a common factor of y. Taking that out gives me y times y minus 5. And the factors in my LCD were, in any order, y minus 2, y minus 3, and y minus 5. The point of factoring the numerator is just to check and see if there are any common factors that we can take out at the very end, and it turns out that yes, there are. We do have a common factor of y minus 5, and this leaves us just y in the numerator and y minus 2 times y minus 3 in the denominator. Conceptually, this isn't any more difficult than any of the other subtraction of rational expressions that we've done so far. However, there are lots of opportunities to make mistakes, either sign errors or cancellation errors, and those little things are what make this problem difficult. I want to call attention again to this step right here where we had written out the numerator with those factors in parentheses, but we hadn't started to multiply it out yet. At this step, especially if we had the factors written in the denominator instead of the letters LCD, sometimes these factors, y minus 3 and y minus 2, look a little bit tempting to cancel out with one of the factors in the LCD. It will always be the case that those factors are repeated in the LCD. That's what got them there in the first place. But we can't cancel anything at this stage, really because this is still a subtraction problem. So remember that this is not a factored numerator. This is two terms still. These two large, complicated terms are being subtracted, and it's only when the whole numerator is actually factored that we're allowed to start doing that. So there's never a shortcut. It is always necessary to multiply these all the way out, expand that numerator as much as possible before then collapsing it back down by combining like terms, then looking for common factors in that very last step. So we want to be careful to know what to do in addition to what not to do. Sometimes a long expression like that with what appear to be common factors is just a little too hard to resist.